In this particular exercise, we are going to graph a function using transformations. We are given the exercise to graph f of x is equal to the negative absolute value of x minus 3 plus 2. Well, let's determine what each of these different pieces means. The 3 is subtracted within the absolute value bars themselves. When this happens, this means we are to move our vertex, and thus our entire graph, to the right 3 places. On the outside of the absolute value bars, we see a plus 2. Transformations that are vertical will come on the outside. So plus 2 means our graph will shift up 2 places. Now, the negative on the outside means that we will have a reflection, and our graph will turn from opening upwards to opening downwards. Let's go ahead and start by plotting the vertex of our particular absolute value equation here. Instead of having a vertex at 0, 0, the origin, the vertex will now be at 1, 2, 3 across, 2 up. Now, normally we'd have an upwards facing V this time, but now we will consider one that is opening downwards because of the negative reflection. Let's go ahead and get a couple more points present on this. Let's find the x-intercepts of the graph. Recall, in order to find the x-intercepts, we would set our equation equal to 0 in order to solve. I will subtract 2 to both sides. Now, if negative 2 is equal to a negative absolute value of x minus 3. Dividing by a negative, I'll have 2 equals the absolute value of x minus 3. And I will set an x minus 3 equal to a 2 as well as a negative 2 in order to find my x-intercepts. Adding over accordingly, I'll have that x is equal to 5 and x is equal to 1. So I will have x-intercepts occurring at 1, 0, as well as 5, 0. Thus, from here, we can make our graph. When graphing transformations, perform horizontal and vertical first, and then consider your reflections.